National 5 biologists, I've been asked to do some problem solving skills, some of the skills that are involved in the National 5 biology paper. So we're going to run through a few series of these videos, looking at calculations, looking at graphs, looking at relationships, looking at all the skills that you need in addition to the knowledge for the exam. So we've already done a couple of videos, but we're now on to looking at these skills here, okay? So what I've done is I've put up a set of data here. This is a typical set of data for temperature against enzyme activity, for example, okay? Now the data itself isn't massively important. What's more important is what we actually do with that data, you know, the skills that are involved with doing something with it. So we'll have a look at the data first, and then we'll see what the skills are. So the temperatures go up from 10 all the way up to 60 degrees, and the enzyme activity is going up from 5 to 90 at 40 degrees, and then down to 0 by 60 degrees, okay? That's the kind of thing we would expect when we're looking at the effective temperature on enzyme activity, particularly if it's a human enzyme, for example. So skill 1, draw a line graph, okay? Now the SQA will provide you with a grid on which to draw your line graph, and sometimes they even give you some of the grid filled in, okay? They might give you like a bar filled in, or they might give you an axis filled in, or something similar, okay? Now because we've been asked to do a line graph, you have to make sure when you're reading the question in the exam that the graph you're actually asked to do is the one that you produce, okay? Because you can be asked to do a pie chart, a bar graph, or a line graph, so you need to be able to choose the right one. Now the line graph is probably the trickiest of the three, so we'll cover how to do that one just now. So the first thing we need to do is we need to label the axes. Now a little rule that makes it pretty easy to decide where the labels go for the axes is just to look at your table. The column here on the left hand side, the first column is usually what goes here on the bottom axis, and the label on the second column of the table there is usually what goes on the vertical axis, okay? So I'm going to pop that on there just now. So we've got temperature, and note that I'm writing the full thing and I'm putting in the units, okay? That's important. Enzyme activity up the side here, okay, so I'll just write enzyme activity, and that's measured in percentage, okay. Now in reality, if we were doing an enzyme experiment, we'd have an indirect measurement of enzyme activity, but I'm just doing this to make it a little bit easier for us as we do this just now, okay. So let's use the black pen here for the values. Now the first thing to note is you probably want to put a 0 at the start of these two axes because they are continuous sets of data, okay? They go from 0 up to a particular number. Now, the temperature goes from 0 all the way up to 60, okay? So we're going to need to put in values at 10, 20, 30, 40, 50, and 60 degrees there, like that, okay? Now on the graph that you're provided by the SQA, they generally tend to give you the right number of spaces on the axes to fill in the data nicely, okay? So if you're, for whatever reason, when you're filling in the scale and it feels like it's wrong, it probably is. So double check it and have another go at it, because the SQA, as I say, they tend to give you enough boxes that it'll fit in all the data that you need, okay? Up the side here we've got enzyme activity. Now the highest value for enzyme activity is 90, so we need a scale that goes up to 90, okay? So we've got 10, 20, 30, 40, 50, 60, 70, 80, and 90 up there, okay? Now what we need to do is we need to plot that data. So at 10 degrees it's 5 for enzyme activity, so that'll be here. For 20 degrees, we're up to 30 for the enzyme activity, so that'll be up here. For 30 degrees, we're up to 70, so 30, we go all the way up to 70 up here. For 40 degrees, we're at 90, so 40 degrees, we go all the way up to 90 there. 50 degrees, we're back down to 40. Okay, so that's roughly here. And 60 is back down to 0, so that's going to be here. Okay, now in your exam, once you've plotted all your points, you're going to join those points with a straight line with a ruler. Okay, now I'm just going to very quickly join these up just so you guys can see. Okay, I'm just going to use dashed lines just to join up these dots, just so we can quickly see the trend, because that's the key thing here. Okay, so you guys will use a ruler and draw straight lines. Okay, and you can see the nice trend that we've produced based on our data. Now, one thing to remember as well, I see students do this a lot. In other subjects, you're sometimes asked to draw a curve for a line of best fit. We in biology don't do that, we simply join the dots, okay? And you do not need a line that goes down to the 00 there, okay? I know sometimes that's a thing you ask to do in maths and other subjects, but we don't need a line going down to the origin, okay? We don't need that in biology. Right, so we've drawn our line graph there, okay? As long as we've labelled it correctly with the units, we've got the scale right, and we've plotted it correctly, we'll get the 2 marks for that question. Okay, question 2. How many times greater is the activity at 40 degrees compared to 10 degrees? Well, let's look at the activity at 40 degrees. Now, the activity at 40 degrees is 90, okay? The activity at 10 degrees is 5, okay? So, we've got 90 and we've got 5. Now, in order to work out how many times greater or how many times smaller a number is than another one, this is the little formula you use, okay? It's not much of a formula, to be honest, but it's just a little way to remember it. You do big divided by small. If you do the big number divided by a small number, you can work out how many times greater that number is, the big number is, or how many times smaller the smaller number is. Okay, so in this case our numbers are 90 and 5, so we're going to do 90 divided by 5, which is going to give us 18. Okay, so 90 divided by 5 is going to give us 18. So it's 18 times greater at 40 degrees than it is at 5. Okay, so hopefully that skill is an easy one for you guys to remember for the exam. Now lastly, this is one which is an important one to get right because it's often worth 2 marks in the exam, okay? Especially if it's a graph like this where there's a couple of different changes in terms of the way it goes. Some graphs, you know, it continually increases, that's only going to be worth 1 mark. But if there's a change, i.e. it levels off or it starts to decrease again, it's going to be worth 2 marks, and you have to be able to describe this correctly, okay? So there's a little way to answer these questions which is the same for every single time you do it, and that's to do the following. Start off by saying as the, okay? So as the, and then we go to what's in the bottom here, okay? Whatever's at the bottom of your graph is the first thing that you're going to mention, okay? So in this case we're going to say as the temperature. Now what is the temperature doing on that scale? What's happening to it in the experiment? It is increasing, okay? So as the temperature increases. Okay, now the second part of this is going to be the, now the next word we're going to say is what we put on the other axis, okay? So we're going to say the enzyme activity. Now, what happens here with the enzyme activity? Well, initially, as we increase the temperature, the enzyme activity is increasing. So we'll write that. Okay, so the enzyme activity increases. Okay. Now, at this stage, things get a wee bit tricky because it doesn't continue to increase, it actually falls again. So we need to put in until, okay, that's a key word there, until, and then we're going to talk about the change. Now, we're going to find the temperature where it all changes, which is 40 degrees, okay? So we're going to say until, and then in our answer we're going to write 40 degrees. Now, by putting a value in, we're showing the marker that we understand where the change has happened, okay? So it is important you use a value when you're describing the change in a relationship. So until 40 degrees, where the enzyme activity, what happens to that? The enzyme activity, what is happening to it there? Starts to decrease, okay? Or it decreases. Okay, so that's how you get the 2 marks for that relationship question. And when you get a relationship question, you always answer it in the same sort of format as what I've shown you here, okay? So if you want to know how to do these skills, you can take a screenshot, you can favourite this video, or you can follow me for more, where I'm going to be talking lots more about exam technique and the way to go about answering these styles of questions. Okay folks, I'll see you in the next one.